Hello everyone. Today we will discuss advanced prompt engineering for Claude. In this lecture, we will understand prompt engineering and why it is important in modern AI systems. Prompt engineering is the process of designing instructions that guide the behavior of large language models. The way a prompt is written has a direct impact on the output of the model. The same model can produce very different results depending on how the prompt is structured. In production systems, prompt engineering is treated as a core engineering discipline rather than something secondary. Now, let's understand why prompt engineering matters. A model's output quality depends heavily on the prompt. If the prompt is weak, meaning it is vague, unstructured, or missing context, the output will likely be inconsistent and unreliable. On the other hand, a strong prompt includes clear role instructions, structured context, and a defined output format. This leads to responses that are more accurate, consistent, and useful. Prompt quality directly affects accuracy, reasoning quality, consistency across requests, and how well the output is structured. Next, we look at the anatomy of a production prompt. In real-world systems, prompts are not simple sentences, but structured templates. A production prompt typically has four main components. The first is system instructions, which define the role and rules for the model. The second is context, which includes any injected knowledge such as retrieved data. The third is the user query, which is the actual question being asked. The fourth is the output format, which specifies how the response should be structured. Treating prompts as structured and reusable components is what separates production AI systems from simple prototypes. System prompts play a very important role in shaping model behavior. They define who the model is, what level of expertise it has, how it communicates, and how it should structure its responses. A well-designed system prompt also includes rules and constraints, such as avoiding speculation or always providing structured answers. This ensures consistency and reliability across all responses. Moving on to context injection, this technique ensures that the model uses real and relevant data instead of relying only on its training knowledge. Context can come from documents, databases, retrieved knowledge, or enterprise systems. By injecting this context directly into the prompt, the model produces more accurate and grounded responses. This approach is commonly used in retrieval-augmented generation systems. Another important technique is few-shot prompting. In this approach, we provide examples directly in the prompt to show the model how to respond. Instead of just describing the expected format, we demonstrate it with sample inputs and outputs. This helps the model learn the pattern and produce consistent responses, especially for structured tasks like JSON outputs or classifications. Chain of thought prompting is used to improve reasoning. In this method, the model is instructed to explain its reasoning step by step before giving the final answer. This is particularly useful for complex problems, logical reasoning, and multi-step tasks, where intermediate steps are important for arriving at the correct conclusion. Structured output prompting is essential for integrating AI with real systems. By defining a strict output format, such as JSON, the model can produce machine-readable responses. This makes it easier to parse the output and use it in APIs or automated workflows. In production systems, structured outputs are often required rather than free-form text. Safety and guardrail prompts are used to control model behavior and ensure compliance with rules. These prompts define what the model is allowed to do and what it must avoid. For example, they can prevent harmful content, restrict the domain of responses, and ensure that the model does not reveal sensitive information. Safety is a critical requirement in enterprise AI systems. Prompt templates help standardize how prompts are constructed. Instead of writing prompts manually each time, templates define a consistent structure with placeholders for system instructions, context, user queries, and output format. This ensures consistency across all requests and makes prompts easier to maintain and update. Prompt versioning is another important concept. Prompts are stored with version numbers, allowing teams to improve them over time without changing application code. Different versions can be tested, compared, and rolled out gradually. If a new version performs poorly, it can be quickly replaced with a previous one. Prompt evaluation is used to measure the quality of prompts. This involves testing prompts against a data set and evaluating them based on accuracy, relevance, and consistency. Automated evaluation helps identify issues and ensures that prompt changes do not degrade performance. Prompt optimization is an iterative process. It starts with an initial prompt, which is then tested and refined based on evaluation results. This cycle continues until the desired performance is achieved. In production, real user feedback and system logs are also used to continuously improve prompts. Dynamic prompt construction takes this a step further by building prompts at runtime. The system retrieves the latest system prompt, gathers relevant context, and combines everything with the user query using a template. This makes each prompt personalized and context-aware while maintaining a consistent structure. Finally, production prompt architecture centralizes all prompt construction into a single component, often called a prompt builder. This ensures that every request follows the same structure and rules. It also makes the system more maintainable, consistent, and auditable. There are also common mistakes in prompt engineering that should be avoided. These include vague instructions, missing output formats, too much irrelevant context, unclear task definitions, and hard-coding prompts in source code. These issues often lead to poor and inconsistent results. To conclude, there are 5 key best practices for prompt engineering. Always be clear and explicit in instructions. Use structured templates for consistency. Provide examples to guide the model. Test and evaluate every change. And finally, include safety guardrails in every system prompt. Following these principles leads to reliable, maintainable, and production-ready AI systems. Thank you.